Okay, hello Math Wizards. Now we are on a new chapter in our Mathematics 9. So we will be having quadratic function. So a function is a relation between two variables and somewhat it represents a scenario or it could be a model of a certain phenomenon that we have in our daily life. I have here three situations that we are going to analyze, and which one of them is a function that gives us a quadratic function. Let's say a function of the amount of payment to the number of kilograms of apples. So let's have another one, which is the function of the height reach of an object thrown upward with respect to time. The function of the slices of pizza to the number of persons sharing the whole pizza. So in this scenario, we could identify that the first and the last situation will give us a linear function. And the second one gives us a model of a quadratic function. Let us move on and try to identify more and learn about the situations that models a quadratic function. So there are several types of applications that we real life situations that we can relate to quadratic function. One is shooting a basketball to a basketball ring. The other one is a model of firing a cannon. The other one is when a person dives from a platform. And the other one could be a person hitting a golf ball. And lastly, quadratic function is a model when a person go through a skate ramp. So I have here the function f of x is equal to 2x plus 1 and g of x is equal to x squared plus 2x minus 1. The first function is a linear function and the other one is a quadratic one. So let us compare. Given the two sets of functions, I have here quadratic functions and another set which is not a quadratic function. So with numbers 1, 2, 3, 4, and 5, 6 under quadratic function, we can all see that all of them has a degree which is equal to 2, or the highest exponent present in one of the variables is equal to 2. It involves two variables which is x and the other one is y, the same as what we can see in number 3 and 4. Aside from that, we could also denote one of the variables as f of x. This one indicates that it is a function in terms of x. On the other hand, we have not quadratic functions. They are functions, but they are not a model of a quadratic function. Why? On equation 1, we could see that it is a linear function where the degree is equal to 1. The second one is an exponential function where the variable is in the exponent of a number. On number 3, we could see that the highest degree present in the function is equal to 3. On the other hand, number 4 involves radicals. And lastly, on number 5, as we distribute x in the group x squared plus 7x minus 1, we could have a degree equal to 3. Now let's look back on the two equations that we had earlier. So we have here linear and quadratic. The degree of linear is equal to 1, while the degree of a quadratic function is always equal to 2. Let us complete the table by evaluating the values of x in the table of values to compute for the output or the value of f of x, or maybe it could be the value of y. Okay, let us evaluate first the values of y in the linear function. So for us to evaluate the values of negative 3, negative 2, negative 1, 0, 1, 2, 3 as the values of x, we will be substituting to the function f of x is equal to 2x plus 1. For f of negative 3, we will be having 2 times negative 3 plus 1. f of negative 3 is equal to negative 6 plus 1. f of negative 3 is equal to negative 5. So we could now write our answer negative 5. Now let's have f of negative 2. That is equal to 2 times negative 5 at 2 times negative 2 plus 1. f of negative 2 is equal to negative 4 plus 1. f of negative 2 is equal to negative 3. Moving further, let's have f of negative 1 is equal to 2 times negative 1 plus 1. f of negative 1 is equal to negative 2 plus 1. f of negative 1 is equal to negative 1. Now let's move further. For f of 0 is equal to 2 times 0 plus 1. So f of 0 is equal to 1. f of 1 is equal to 2 times 1 plus 1. f of 1 is equal to 2 plus 1. f of 1 is equal to 3. f of 2 is equal to 2 times 2 plus 1. f of 2 is equal to 4 plus 1. f of 2 is equal to 5. f of 3 is equal to 2 times 3 plus 1. f of 3 is equal to 6 plus 1. f of 3 is equal to 7. Now let's evaluate for the values of x in our table. So we will be having negative 3, negative 2, negative 1, 0, 1, 2, and 3. So again, the same as what we did in the linear function, we will be evaluating each of the values of x to have our value of 1. So g of x is equal to x squared plus 2x minus 1. So let's have g of negative 3 is equal to negative 3 squared plus 2 times negative 3 minus 1. g of negative 3 is equal to 9 minus 6 minus 1. g of negative 3 is equal to 9 minus 7. g of negative 3 is equal to 2. Now let's have g of negative 2. So negative 2 squared plus 2 times negative 2 minus 1. g of negative 2 is equal to 4 minus 4 minus 1. g of negative 2 is equal to negative 1. Now let's have g of negative 1 is equal to negative 1 squared plus 2 times negative 1 minus 1. g of negative 1 is equal to 1 minus 2 minus 1. g of negative 1 is equal to negative 2. Now let's have g of 0 is equal to 0 squared plus 2 times 0 minus 1. g of 0 is equal to 0 plus 0 minus 1. g of 0 is equal to negative 1. g of 1 is equal to 1 squared plus 2 times 1 minus 1. g of 1 is equal to 1 plus 2 minus 1. g of 1 is equal to 2. Now let's have g of 2 is equal to 2 squared plus 2 times 2 minus 1. g of 2 is equal to 4 plus 4 minus 1. g of 2 is equal to 7. g of 3 is equal to 3 squared plus 2 times 3 minus 1. g of 3 is equal to 9 minus 6 minus 1. g of 3 is equal to 9 plus 6. 9 plus 6 plus 5. 9 plus 6 minus 1 is 9 plus 5. 9, g of 3 is equal to 14. Now we are done with completing the table of values for the function g of x is equal to x squared plus 2x minus 1. The table of values that we had is another representation of the function given earlier for f of x is equal to 2x plus 1. Aside from being represented, the function as being presented as an equation, we could also represent them by using the table of values, or we may also represent them by using an ordered set of ordered pairs and a graph. So now let's have the difference between the values of our y. So having the first difference for the linear function f of x is equal to 2x plus 1, you will notice that the first difference are all equal. So negative 3 minus negative 5 is equal to 2. Negative 1 minus negative 3 will give you also 2. 1 minus negative 1 will give you equal to 2. 3 minus 1 is equal to 2. 5 minus 3 is equal to 2. And 7 minus 5 is equal to 2. Moving further, getting the first difference for the quadratic function, we could see that there are varied answers in the first difference of there are varied answers in the first difference of the function in the first difference of the y values of our table for the function g of x is equal to x squared plus 2x minus 1. Trying to get the difference of the first differences, we will have the second difference, and the result of the second difference will give you equal answers. So in this case, we could say that the quadratic function always will have the same second difference. Moving further, if we have given table of values for us to identify if it is a quadratic function or not, if the second difference of a given table of values are equal, then we could say that the given function is a quadratic function. Moving on, let's have the graph representation of the two given functions. We could identify that the graph of f of x is equal to 2x plus 1 gives us a line. While on the other hand, the graph of g of x is equal to x squared plus 2x minus 1 will give us a parabola or a parabolic graph. A quadratic function always have a parabolic graph. It is either upward or downward. So now let's have the properties of each function. For f of x is equal to mx plus b, it is a linear function with a degree equal to 1, a graph which is a line, and given a table of values, we could notice that it has equal values on the first differences. On the other hand, we have g of x is equal to ax squared plus bx plus c. It is a quadratic function. A quadratic function has degree 2. The graph is a parabola, and given the table of values, we could notice that there are equal values on the second difference. Now let's have practice exercises. Try to answer the following. Choose the letter that corresponds to the correct answer. If your answer is not among the choices, write E. What is the degree of the quadratic function? A, 1, B, 2, C, 3, D, 0. Number 2. Represent the situation. The area of a rectangular lot with the length 3 more than twice the width as a quadratic function. A. F of x is equal to x times the quantity 2x plus 3. B. f of x is equal to 3x times the quantity 2x plus 1. C. f of x is equal to 2x times the quantity x plus 3. And D. f of x is equal to x times the quantity x plus 3. Now let's have number 3. Which of the following situations represents a quadratic function? A function of the fare rates of a taxi to the distance traveled. The function of the amount of payment to the number of kilograms of apples. The function of the height reached of an object thrown upward with respect to time. The function of the slices of pizza to the number of persons sharing the whole pizza. Number 4. What is the graph of a quadratic function? A. Line. B. Parabola. C. Circle. And D. None. Which of the following table of values shows a quadratic function? Check your work on the next video. Like, share, and comment your suggestions on the comment box below, and don't forget to subscribe. To get notified with our latest videos, just click the notification